In this video, we'll be looking at the definition of a function. Like, what exactly is a function? So actually, you've probably already worked with functions many times. If you've worked with the equation of a line, chances are most of those lines have been functions. If you've worked with quadratics, they've been functions as well for the most part. So exactly what is a function? Well, a function is a mathematical relation that takes an input value and gets you to an output value. So the input value is the x, and the output value is the y. Now, there is another criteria to make sure that it is a function. So each input value, each x value, can have only one y value. So for example, if I have a bunch of x values here and a bunch of y values here, let's say my x values are -2, -1, 0, 1, and 2. And let's say my function is x squared. So my y values would be 4, 1, and 0. Now, in this particular case, 2 would go to 4, sorry, -2 would go to 4. -1 would go to 1, 0 would go to 0, 1 would also go to 1, and 2 would also go to 4. Now, it's completely okay to have our y values, or output values on this side, can have more than one x value coming to it. So you see how 4 has multiple things that matches, multiple x values match, and how 1 has multiple x values that matches with 1. That's completely okay, as long as each x value has only one y value that goes with it. So for this reason, this is a function. However, if I had instead the other way around, so if my input values were, I'll just throw this up here, if my input values were, so let's say 1, 2, and 3, and my output values were 1, 4, and 9, I'm just making something up here, and let's say 1 went to 1 and 4 also went to 1, then this would not be a function. And the reason is, again, for it to be a function, for that relationship to be a function, the x can't have more than one y value coming to it. You might want to think about relationships and how they work, and these guys over here only allowed to have one of those guys, but for some reason these guys over here, they can have multiple people. Well, just think about it that way, maybe you'll remember. Alright, so with that said, let's look at some coordinate pairs and see if we can figure out whether or not they're functions. Okay, so in this example we have x, y, 5 and 1, we have x, y as 5 and 3, and we have x, y as 5 and 5. And the question, is this a function? Well, we have 5 as our x value more than once, and it's going out with more than one different y values. That's not allowed for a function, so this is actually not a function. Remember that the x can have only one y, so that is not a function. Alright, let's try another one. Okay, so in this case I switched it around. I switched the order. So we have here xy, xy, and xy. Well, remember that the x's are allowed only one y, but the y's can have as many x's as they want. Not fair, but that's just the way it is. So because each x has only one y, this x has only one y, and it's 5, this x has only one y, and this x has only one y, this is actually, in fact, a function. Alright, let's try one more of these, and then I'll show you how to figure out if it's a function within a visual context, within a graph. Alright, so here, looking at this, each x has only one y. This x has only one y. This x has only one y, and this x has only one y. So yes, it is a function. Alright, so now we're ready to look at a graph, and we can see how to use that visual to figure out whether or not something is a function. Okay, so there's something called the vertical line test, and you can use it to see whether or not something is a function or not a function. So for example, if I have a parabola in a coordinate plane, so this is my x-axis, this is my y-axis, and the black is my graph. If I can draw a vertical line anywhere in this coordinate plane that touches that graph more than once, then it's not a function. So this is my graph here. I'm tracing it with this arrow. That's my graph. If I can draw a vertical line anywhere that touches this graph more than once, it's not a function. So I'm drawing a vertical line here. Yes, there are many places I could have drawn this vertical line, but the same thing will probably happen. It will hit the graph only once. So because that vertical line hits the graph only once, this is in fact a function. Let's try another one. Circles are pretty common, so let's get one of those up here. Alright, so here is my graph, the circle, or my attempt at a circle. Now, if I can draw a vertical line anywhere on that coordinate plane and it touches my graph more than once, it's not a function. Well, here we go. It does touch the graph twice. Therefore, this is actually not a function. You may argue, though, that if I were to draw my vertical line here, it only touches once. Well, I need to stress the point that if I can draw a vertical line anywhere that touches more than once, then it's not a function. All right, let's try one more. All right, so we have my coordinate plane going here, and we have a graph that looks like this. I know I'm going way too far here. All right, let's stretch my coordinate plane. All right, so that's a pretty wide graph. It's going and going and going. Can I draw a line anywhere that touches this graph more than once, a vertical line? I could try. No, it touches only once, only once, only once, and only once. This is actually a function. So the reason that this vertical line test works is because remember that each x value is allowed only one y value. If it's touching more than once, like it did here in our circle, that x value, let's say that x value was 1, actually has two y values. So this could have been like 1, 3 and 1, -3. And that's totally not allowed, which is why this is not a function. All right, that's it for now.